So in this problem, we need to determine the equation of a parabola with vertex at 2, 1 and the equation of the directrix as given as x equals to y minus 1. Let us begin. So we'll try to understand the problem graphically first. So we begin by considering the straight line which is going to represent the directrix. Now, this line has the equation given by x equals to y minus 1. Now let's rewrite it as x minus y plus 1 equals to 0. Next, what we'll do, we'll consider another line which is perpendicular to this directrix line. Now this line is chosen in such a way such that the vertex having the coordinates 2, 1 lie on this particular line. Let's call the vertex as v with the coordinates 2, 1. Now from the definition of a parabola, any point of vertex that lies on this line will be referred to as the axis of symmetry line. On this line, there is also going to lie the focus of the parabola f. Now, our goal will be to determine the focus of the parabola first if we are to find out the equation of the parabola, because to find out the equation of the parabola, we need the coordinates of the focus and the equation of the directrix. However, in our case, we are not provided with the coordinates of the focus. We are only provided with the coordinates of the vertex. But the problem is symmetric in nature. It means that the vertex is always going to be midway between the directrix and the focus. That means this distance from the directrix line of the vertex will be exactly equals to the distance between the vertex and the focus of the parabola. So our goal will be to first determine the coordinates of the focus. How shall we do that? We'll try to find out the coordinates of the intersection of the directrix line and the axis of symmetry line. Let's say this is the point. Let's call it point A and we're going to name it x2, y2. Now if we can find out the coordinates of point A, then we can use the midpoint formula to find out the coordinates of point A. Now why we are trying to find out the coordinates of point A? Because we can easily obtain the equation of the axis of symmetry line. So when we take the equation of the directrix line and the equation of the axis of symmetry line, we can easily find out the coordinates of point A. Okay, so let us begin. Now it's given here that the equation of the directrix is x equals to y minus 1. But we can rewrite it as y equals to x plus 1. The reason why we're writing in this particular fashion, we're going to compare with the slope-intercept form of a line, which is given by y equals to mx plus c. So that means the slope, let's call it m1. The slope of the directrix line will be equals to the coefficient of x. The coefficient of x is 1. So that means our slope of the directrix line will be equals to 1. Now, we're going to consider the slope of the axis of symmetry line. So let the slope of the axis of symmetry line. We'll consider that the slope of the axis of symmetry line be given by m2. Now since the axis of symmetry line and the directrix lines are perpendicular to each other, then from the properties of straight line, the product m1 times m2 must be equals to -1. And since we already have the slope of the directrix line, so that means the slope of the axis of symmetry line will be equals to -1 divided by m1, and we have already stated that the value of m1 equals to 1. So that means the slope of the axis of symmetry line is going to be -1. Now we have the axis of symmetry line having a slope of -1 and it passes through the point 2, 1. So using the point slope form of a line, we can easily obtain the equation of the axis of symmetry line. So to find out the equation of the axis of symmetry line, we use the point slope form, which states that if we have a point with the coordinates x1, y1, and through this point, if we have a line passing having a slope given by m, then the equation is given by y minus y1 equals to the slope times x minus x1. Now in a case, x1, y1 will be corresponding to the value 2, 1, and the m will represent the slope of the line. Now that means we have y minus y1. So y1 will correspond to the y coordinate of the vertex, that's 1. That will be equals to the slope, which is -1, multiplied to x minus x1. So x1 will be the x coordinate of the vertex. So that's 2. Now let's solve this. Well, we're going to get y minus 1 equals to -x plus 2. Or simply put, we have x plus y equals to 3. So this is going to be the equation of the axis of symmetry line. So now what we can do, we can solve y equals to x plus 1, which is the equation of the directrix, and the equation of the axis of symmetry line to find out the coordinates of point A. That means find out the value of x2 comma y2. So what we'll do, we're going to add the two equations. We have x minus y equals to negative 1 and x plus y equals to positive 3. So adding them, the x and x gets added to give us 2x. Negative y and positive y gets cancelled out. 3 added to negative 1 is simply 2, which means that the value of x comes out to be equals to 1. Now we can use either this equation or this equation to find out the value of y. So y will be equals to 2. So that means x2, y2, which we have chosen as the coordinates of the point A, which is the intersection point of the axis of symmetry line as in the directrix line. So that came out as 1, 2. Now let's go back to the diagram. So here x2, y2 corresponds to 1, 2. Now what we can do, we can use the midpoint formula to obtain the coordinates of the focus. The focus F, to define it, all we have to do is add the coordinates of point A, x coordinate of point A, and the x coordinate of the focus. So we get 1 plus x1. We're going to divide it by 2. And then we have the y coordinates, sum of the y coordinates of A and F. So that means we have 2 added to y1 divided by 2. And this coordinate value will be exactly equals to the coordinates of the vertex B, 2, 1. So when we equate it, we're going to get 1 plus x1 divided by 2 will be equals to 2. And we have 2 plus y1 divided by 2 equals to 1. So we get 1 plus x1 equals to 4. So x1 is going to be equals to 3. And then we have 2 plus y1 equals to 2. So 2 and 2 gets cancelled. So that leaves us y1 value with 0. So that means we now have the coordinates of the focus, which is 3, 0. Now what we'll do, we'll use the equation of the directrix and the coordinate value of the focus to find out the equation of the parabola. So let us begin. So here we have the coordinates of the focus and the equation of the directrix. To find out the equation of the parabola, we'll begin by considering a point P having the coordinates h, k. So P is going to be the locus of the parabola. To find out the equation, what we'll do, we'll first join point P and point F and then drop a perpendicular from point P onto the directrix lines. Let's say it meets the directrix lines at M. By definition, we know that the length of PF will be exactly equals to the length of PM. So that's the definition of a parabola. The locus of the point P is chosen in such a way that PF equals PM. Now what's PF? PF is the length of the line joining point P and point F, which can be easily obtained by using the distance formula. So we'll take the square root. Underneath the square root, we take the difference of the x coordinates. So that's h minus 3 whole squared added to the difference of the y coordinates. So that's k minus 0 whole squared. Now, to find out the length of PM, this is the perpendicular distance or perpendicular length of the point P from the directrix line. So there's a standard formula to find out the perpendicular length. All we have to do is take the absolute value underneath that. So inside the absolute value, we'll take a ratio. In the numerator, we'll consider the coefficient of x of the directrix line. So that's 1. 1 will get multiplied to the x coordinate of the point P. So that's h added to, now we'll take the coefficient of y of the straight line or the directrix line. So that's negative 1. Negative 1 gets multiplied to the y coordinate of point P. So that's k. And then to it, we are going to add the constant term. So that's positive 1. Divided by the square root of, so inside the square root, we have to take the sum of the squares of the coefficient of x. That means we'll take 1 squared and add it to negative 1 squared. Now our goal will be to simplify this. We'll take the square on both sides. So we get h minus 3 whole squared plus k squared. That will be equals to, we have h minus k plus 1. We'll take the square and divided by, we have square root of 2. So that's simply going to give us 2. When we simplify this, we're going to get h squared plus k squared minus 14h plus 2k plus 2 times hk plus 17 equals to 0. Now, to finally find out the equation of the parabola, replace the value of h with x and the value of k with y. So we get x squared plus y squared minus 14x plus 2y plus 2 times xy plus 17 equals to 0. So this is going to be the equation of the parabola.